Hello, everybody. It's the final session of the day. Today we have Cynthia Ukawu, and she worked at GACCRI, and she has a lot of experience using PySpark from her years in the industry.
Thanks. Hi, everyone. Like he said, I'm Cynthia, and I've used PySpark before in my last role when I was somewhere in between the role of an analyst and a data engineer. I worked at a mobility analytics company where it was under like a Allstate. So what we did was we would take in lots of payloads from different drivers because people would like plug in devices into their cars. And we get in like petabytes of information and also through their mobile apps as well. And this data was a lot, and we wanted to, the team that I was on would do transformations on this data and hand it over to our customers, which were data scientists who worked internally. So we did a lot of the work to make sure that the data sets that they were using were good to run analysis on and also feed into models and whatnot. So they didn't have to do all that extra work. But since we were working with so much data, as you can imagine, I got to experience what Spark is. And this workshop is for individuals who have experience using Pandas or maybe even Excel in the past to do analysis work. But maybe you started working with big data and you want to do more heavy-duty data processing and analysis on whatever it is that you have. So this is what that workshop is for. So it's broken into 3 different sections. We're going to talk about what Spark is, how it came to be. Then we're going to dive into the architecture of Spark, and then we're going to go over some common functions, ways to clean your data, prep it, some comparisons between PySpark and also Pandas. I will be asking some questions in between, like discussion questions, just to see, like, to gauge people's understanding. This is the first time I'm actually doing this workshop, so I don't know if I'm going to go overboard because there's a lot of information, especially when it comes to like the Colab sheet, which I guess we could if. Okay, so a lot of you have your laptops. I was thinking of having this be more of like a walkthrough, but if you want to run the code in the cells, you can. It will take about 6 minutes or 6 to 7 minutes because the data that I am using is quite large. So to go to the Colab link, let's if you go to the PyData Virginia conference, I have the link there. It's in my, I think it's in the description. Awesome. I'm taking the long road. Should have had this bookmark. So yeah, you'll see the link here, and you can follow along when I'm on the Colab as well. So yeah, let's go ahead and get this started. Oh, well, before we get this started, I want to ask the group, have you ever worked with a large data set in Excel or Pandas? And if so, how was your experience with that? Does anyone want to share? Yeah.
If you get too big of a data set in Excel or just start using like array formulas, it's just gonna crash on you.
Mm-hmm. Yeah, I've experienced that. Yeah. Anyone else want to share horror stories of working with big data on Excel? Excel. Yeah. Well, so hopefully you'll come out with being Spark experts and applying what you learned here. So a little bit about the background behind Spark. We'll start with MapReduce. So back in the early 2000s, Google created this nifty algorithm called MapReduce. And the tech community was like, wow, this is amazing stuff. So what is MapReduce? It's a way to process big data by basically taking a large process, breaking it up into smaller pieces, and then sending it out to different nodes. And each node is going to work on that task in parallel. So the mapping part is breaking down that big problem into a smaller problem. And the reduce part is where each node is working on a particular task. And then at the end, it's all aggregated together to create your final result. So in 2004, Google created that white paper. And then in 2009, developers from Yahoo, I forget their name, but they made Hadoop as like an implementation of MapReduce. And a lot of developers back then were like, wow, this is great stuff. And also during the early 2000s, a lot more people were using the internet. So there was like a boom in data because there was a lot more like e-commerce going on. Also, the rise of social media was going on in the like 2009 to 2010-ish era. So a big data boom back then. So the developers of Yahoo created Hadoop. And with Hadoop, developers could process large amounts of data using the MapReduce paradigm. However, there was issues with Hadoop. So one of the main issues was that this process was very slow and clunky. So with Hadoop, you have this large data set, you're applying all these transformations, but in between each step, you're doing a write to disk and you're doing a read into Hadoop. So if you were to do like a simple pipeline where you're taking this large data set and you want to clean it, filter it, do an aggregate on it, think of all the different, like, I'm trying to put this into like Python. Think of like you working with the Python data frame and all the functions that you do to prep it and do a bunch of analysis or aggregates on it. Like every time you do a function call on that data frame, it gets written to disk and then it gets read back in. So this process took a very long time and developers were not happy with it because you're working with terabytes of data and you're doing this input and output all the time. So that was a huge bottleneck back then. So then Spark comes in and it helped relieve that issue of writing to disk and then reading from disk. So with Spark, what you're doing is you're loading in that data frame into memory, making it fast. So you're no longer writing intermediate results to disk and keeping data, and you're keeping as much data in RAM as possible. And also, Spark allows for lazy evaluation. We'll go over that. DAGs, SQL API. It allows for streaming, machine learning, and also graph processing. And not to mention that it's also developer friendly. So with Hadoop, you could only write this code in a JVM language. So like Java, Kotlin, or Scala. But with Spark, you can write it in a JVM language or in R or in Python, which is why we're here, PySpark. So I think I had another question. Actually, no, I don't. All right. So that was Spark's solution. And now we have some issues with Excel or Pandas that we kind of discussed about earlier, where if you try to load a large data frame into it, you've probably experienced slowdown or crashing. So hopefully PySpark is a solution for that. Let's see here. Oh, I didn't want to talk about the CPU stuff. So with Excel and Pandas, you're running all your code on a single machine, and that uses a single CPU core. And you also have limited memory too. So once you exceed that, performance collapses. And some of you may be thinking like, oh, well, if I'm running a Spark job on that same computer that Excel and Pandas is on, what makes that different? Like, how is it possible that I can, I guess what makes it different? Like, I still have the same CPU or memory, or I'm still limited to the same resources that Pandas and Excel is experiencing. And you're not wrong to question that, you are. But under the hood, Spark works kind of differently. So when a job is created, let me know if I'm being too technical. And if anyone has any questions, you can like interrupt me and ask away. So in the background, when you start a Spark job, a JVM process is up and running. And in that JVM process, there's multiple different threads. So you have a thread for your master node. And this is like the brain of the operation. It sends jobs or tasks over. And then you also have separate different threads for an executor. And these executor threads are like executor nodes. So Spark is still utilizing the same architecture even though it's working on your local machine. And you may be wondering, so then why would I want to use PySpark or Spark on my computer? Well, it's great for prototyping. So if you are an analyst or a data scientist and you have access to large amounts of data and you want to do some like analysis or initial, I guess some EDA or some, well not EDA, but like initial prototyping, or you want to sample that data and feed it into a model later, that is what PySpark is great for. But if you're trying to do like production level jobs, then PySpark wouldn't be the best option. You should probably write it in a more robust language like Scala or Java or something and send that over. Does anyone have any questions there?
How would this compare with, something we talked in the prior session here, using GPUs? Like you could use Python wrappers around CUDA and compute on a GPU, which is much more faster, and you're essentially using all the Python language.
So your question is, how is this different, or how does it compare from using a GPU?
Yeah, are there any pros and cons that we need to sort of keep in mind?
So with a cluster, the cluster manager handles the different types of executor nodes. And each executor node has like its own CPU and memory. I'm not sure about the GPU part because I feel like that's more for like deep learning and whatnot, or maybe I'm not a data scientist, so I really don't know. But each task has its own like memory and storage set aside. I mean, each executor node has its own, resources set aside. I haven't really seen anything for GPU though when it comes to Spark in general. But yeah.
I think the reason why the GPUs is important is when the data is being translated to vectors. Right? The GPU handles vectors in parallel and has all kinds of fits. Most of the jobs you set up on PySpark, they're not being translated to vectors. You're using raw data and you're doing analysis against that data.
Plus GPU is expensive. Because PySpark can run on CPUs, why use GPU?
I mean, as long as it runs fast enough.
It's fast enough.
And I think what's interesting, and maybe you'll get into this, is there are machine learning libraries that Spark supports. So I'd be interested in finding out that same question when you're talking about machine learning versus setup jobs. Because I think if I understand it correctly, Spark is used really heavily for kind of like EDA or preparing to go into a model, not necessarily developing a model. But I think there are machine learning libraries that Databricks has built to support that kind of functionality. So I'm not sure the difference there.
Okay. Yeah, I'll go over it towards the end of that. But really good question. Any other questions?
So, I learned a little bit about Dask framework, which kind of uses Python, but it does parallel processing. Single thread type of thing, kind of like Spark, but not exactly. And that's really fast compared to using normal Python. So, do you have any like guidelines to relating with that process? Now it's reached the limit. Let's use PySpark now.
I've never used Dask before, but I would say if you're prototyping, like I mentioned earlier, then maybe using a tool that you're familiar with, like Dask, would be more appropriate than try to learn something new like PySpark. But if you are using Spark for like an ETL pipeline or something like that, then yeah, I would stick to Spark for that. Any other questions? Nope. Okay, awesome. All right, let me make sure my timer's on. Good. All right, so now we're going to go into, I'm going to highlight some of the use cases here So you can use Spark or PySpark for ETL pipelines, batch processing, real-time dashboards and streaming analytics, running SQL queries on large data sets, and machine learning at scale. But the machine learning is kind of simple, I'd say. It's like regression or classification or decision trees. It's not something super like modern, like the deep learning stuff that we have out. So I would not rely on Spark for that. So next we're gonna set up Spark. If you already have the link to Colab, you're off to a good start. Oh, and I also did want to show the difference in code when it comes to Hadoop versus Apache Spark. So this is what the developers back then were really, I guess, struggling with when I mentioned developer friendly. So here, this code is, this is a boilerplate for a word counter, and the developers, they had, oh, you can't even see it. Okay. Now you can see it. Okay, cool. So this is the word count for written in Hadoop, and the developers, they would have to create their own mapper and their own reducer. But with Spark, it already comes with like a mapping function and reduce function for developers to use. So that was really great. So that's just going back to what I said about how Spark was more developer friendly. And this is like about 55 lines of code. Well, this is about 20 lines of code. But hopefully you guys all have the link to Colab, and I'll pause if anyone wants to get that link. It's on my, what's it called, description of this workshop. Everyone good? Okay, awesome. So the data set that we're working with is this Anime Recommendation Database 2020. And hopefully you have a Google account because this data is stored in Google Docs, and I'm going to be mounting to it. If not, you don't need to run each cell. You can just read along and follow through. But to go ahead and get the data, you'll need to go over to that link, and then you'll hit this link here for the Google Drive. You should see this folder. Switch. And what we're going to use is the anime list and the anime.csv. So you can pin this if you hit those three buttons or those three dots, and then you hit organize. You can add a shortcut for that anime list and anime CSV files. And they're so tiny.
Where did you click to get to the anime?
Oh, it's this link here.
And save it to the Google Drive, you said?
Yes, if you can save that or save a link to that or add a shortcut, I meant. Sorry. And we're gonna add the shortcut for both the anime list and the anime CSV. So the anime list contains the user behavior for various different users, and then the anime.csv is just like a list of different series and some descriptions associated with those series. Is everyone okay? Awesome. Okay, so our first cell here is to install PySpark. We're gonna use this shebang pip install PySpark. And let's see if that is able to download. could I get a thumbs up if you're able to have? Okay, awesome.
So I think you touched on it, but I think it went over my head. So like the issue with like utilizing large data and like pandas is like it's using your own memory. If I'm to like read like CSV from like this drive, it's not gonna be in my memory, it's gonna be utilizing something else. And so that's why it's not gonna crash. Like how's
No, it's still utilizing it's still working on a single computer.
Yeah.
And that was the issue before with Pandas. If you were trying to load a large data set or like a large file onto a single machine, it would probably have it crash because you're trying to load it all into RAM, and you're probably using your memory for other applications that are currently running. But the thing here with PySpark is we can set or we can point our code to a cluster. Right now, we're using a local cluster, and this asterisk means we're using all the resources in that local cluster. But in the background, what happens is there's a JVM process that's created, and there are multiple threads that are being created. So you have like a master node, which is on its own thread, then you have executor threads, and each of these executor threads gets like a chunk of that big data. So it still parallelizes the process, or it still parallelizes your big data problem, but you're still using the same resources.
Okay.
Yeah. Hopefully that made sense.
yeah, it does.
Does anyone else have questions? Are we all good? Yeah. Okay. So the next slide we're gonna mount, or the next cell we're gonna mount to Google Drive. And once you have that going, we're gonna create a Spark session. And this is our entry point to Spark. This is what we use to communicate with the cluster. So yeah, I went over this part here. Here we're just setting an app name, and then get or create just means if the Spark session already exists, use it. If not, create it. And then I'm running the Spark version to see if everything's set up properly. Okay. So once you have Spark or the Spark session created, you can now run something like this. You will need to replace this string here to have it match where you saved your anime list CSV file.
The anime list is still downloading for me in a CSV file. That's
Oh, it shouldn't be downloading. If
should
you
be downloading. I had a feeling.
yeah.
I did the same thing. I think, did you click the download on Kaggle itself?
I did. Where was I
Yeah.
supposed to go?
You have to scroll down and in the actual, like underneath the data set, it gives a link to the Google Drive. that the person actually uses.
Can you show that again? Cause I
Yeah.
Thank
I'm
you.
downloading
Yeah,
it.
no problem. It was on the Kaggle page, but I had to search for it.
Okay. So if you're on the Kaggle page, let me refresh it, you should see something that says view more. And when you scroll down, you'll see a link to the Google Drive that contains the files that we're gonna use for, oh, it's so tiny, oh my gosh, sorry. Okay, so yes,
It's so big.
yeah,
And that's why I pressed. So you go.
Cynthia, I think they may also need to see how to add a shortcut and then moving it to the main drive.
Yeah.
Or my drive, your drive.
I just copied it.
Alright.
awesome. So once you are here, where we have the scrapping my enemy list,
It's a Google Drive.
you'll click the three dots here on the side. And then under this organize folder, there's an add shortcut. And then you'll add that shortcut. You'll add this, or you'll click this link and it should add the file to wherever you specify it.
On my Google Drive?
Yeah, on your Google Drive.
And then once it's there, do I have to copy the path into the notebook?
Yes.
You said it'll take like 6 minutes to run?
Yeah.
Yeah, I'm at like 4 now.
Okay. Let me know if you have any other questions while we go through this. I'll give it one more moment. Okay. So here in this cell, we are reading in our anime list CSV and we're storing it into the user's rating DF variable. And I'm inferring the schema to be true. So this is what Spark cooks up in terms of the schema. It thinks that everything is an integer, and for the most part, that's correct. And this cell here, I'm running show, which is similar to df.head or df.tail. It's just showing the first 5 rows in this data frame. And you can explicitly define a schema in Spark. And I have a question for you all. Why might it be beneficial for me to define a schema explicitly rather than have Spark infer it?
So it doesn't have to infer the schema. It will skip inferring it if you provide the schema, it knows the schema to read. Otherwise, it's going to sample the data, infer the schema, and go back to data again.
That's one.
It might get the typings wrong.
That's another.
Explicit is better than
Yeah. So you all three, thanks. So with if you explicitly define a schema, Spark doesn't have to read through the whole data frame, like you mentioned. So that's a added bonus because we're working with petabytes of data or terabytes of, we're just working with large amounts of data, like in a normal production setting. And having Spark read that initial data frame or do a sweep first before it tries to infer is kind of tasking. It provides a lot of overhead. Another thing is type casting, or it enforces typing. So when you define a schema, if you set something to be an integer type and it sees that there is a row where the value is not integer type, it's going to throw an error. Which is quite different from Pandas, because with Pandas you can have it doesn't infer schema, so it's not strictly enforced. In fact, I think with Pandas, if you have like a mixed type, it'll turn that column into an object type, which can be really slow when it comes to like doing analysis work. But yeah, this is just an example of how to explicitly define a schema. Does anyone have any questions there? No? Awesome. So we're gonna do the same thing with the animes list. So if you went ahead and made that shortcut, you're just gonna paste it here and then run this code. And was anyone able to run this command successfully? I heard someone was. Are you still waiting on your code to?
Oh, no, it ran successfully.
Okay, awesome.
Oh, mine just finished.
Yours is done?
Mhm.
Awesome. So yeah, we're just doing
Mine
the.
just finished.
That's great. So we're doing the same thing here with the animes list. So this is the schema that Spark has inferred for us. And is there anything that looks kind of off in this schema? Oh, right. Here, I'll zoom into what I'm looking at. Is there anything that looks off?
Just assuming a lot of nulls.
That could be something to take note of, yeah.
Scores are strings.
Yes, the scores are strings. I would like for the scores to be integers. So in this next cell here, we're going to go into changing a column's data type. So with PySpark, you can run the code Pythonically. I'm not sure if that's a word. But here I am creating a scores column list, and all the scores from 1 through 9, I'm going to go ahead and cast it to an int. Alias is just another way of saying name, so I'm gonna name it the same name as before. And it should change all the scores I have 1 through 9 in it to an int. And I print out my schema, and it shows that it is casted into an int, which is great. And there's another way you can do this as well. You can use with column, and that is a function that comes with Spark. So I'm doing the same thing with score -10. I'm just going ahead and casting it to an int, and I'm also doing the same thing with popularity and rank. And then I print the schema, and as you can see, it is now an integer. Does anyone have any questions there? No? Okay. All right. So in Spark, there are two operations. There's transformations and there's actions. So transformations tell Spark how to manipulate data, while actions trigger an execution. And I want you to remember that transformations build the plan, while actions execute the plan. I did have a question. Let me see if I can find it. Okay. All right, so we're gonna go back to learning more about the architecture of Spark, and we're gonna go back to the transformations versus actions. But first, let's go into the architecture design behind Spark so we can understand what I meant by transformations build the plan while actions execute the plan. First off, we're gonna talk about divide and conquer. Does anyone know what that algorithm is, or want to share your version of divide and conquer?
Distribute the data and the processing.
For divide and conquer?
Yeah.
Any other guess?
So divide and conquer is taking a big problem and dividing it into little pieces.
Mm-hmm.
It can be applied in different places, for instance.
Yeah, So if we combine the two answers, that's what Spark does. So divide and conquer is a recursive algorithm pattern where you take a big problem and you chunk it up into smaller problems. You solve it recursively, and then the results are later aggregated together. So some classic examples are merge sort and also binary search. But with Spark, it's designed to work with distributed data. So we are applying that divide and conquer amongst different nodes within our architecture. So here's a question for you all. If I were to read in a 10 gigabyte file into Pandas versus Spark, how would that differ? Like what? I think that's the question. Okay, yes. So how is Spark reading the CSV any different from Pandas reading a CSV? If I had a 10 gigabyte CSV and I read it into Spark, how is it different from like reading it into Pandas? Does anyone want to take a guess?
Parallel processing, so Spark will, like Pandas is sequential, right? So it'd have to read it all in and order or whatever algorithm it's using, but if you use distributed, maybe this node could read in 100 or 1,000 lines and the next node could read in 1,000. And then it combines it all back together.
Yeah?
Oh,
There's more too.
okay. Well, that was my contribution.
Does anyone else want to take a poke? No worries. So, yes. So with Pandas, that 10 gigabyte file is being read immediately into that data frame. So Pandas is going to try to store it into RAM, but with Spark, it's going to, like you said, split it up into multiple different chunks and then send it out to the different executors for them to work on. But the cool thing about Spark is that it doesn't necessarily do anything or execute right away, unlike Pandas. So Pandas is eager, that's the keyword, while Spark does things lazily. Like there's a lazy evaluation with Spark. So, this is just the architecture. So the master worker architecture, we have the driver, this is our script. This is where we create the Spark session. Cluster manager coordinates the resources across the cluster. A cluster manager could be on Yarn, it could be on Kubernetes. Databricks can host and manage it. What else? We've also got Google Cloud Compute Engines and AWS EC2 can all service your cluster manager. And then we have the executors, and these are like the worker nodes that are doing the task, and then their results get aggregated and sent back to the driver, where the user can see the result or persist it onto disk. So that is the architecture there. I wanted to get into lazy evaluation. So Spark builds a plan for what needs to be done. Unlike Pandas, if I were to load a data frame and apply a function to it, it's immediately going to work on that function. So like if I did a filter, it's immediately going to filter or apply that filter to that data frame and return a data frame. But with Spark, it's going to build a plan, and I'm not going to see anything until I call an action. So lazy evaluations in Spark is Spark's way of building a DAG, and you can think of that as like a workflow. Like these are the steps that need to be done in order to produce the final result for the user. So let's go back to the Google Colab. Oops. I put a timer so that we could like take a 5-minute break, but I don't wanna pause mid thought, so. Okay, back to transformations, build a plan while actions execute the plan. So here we have this cell where we're doing a filter and we're looking for users with a rating of 8, greater than 8. This is a lazy evaluation. Nothing's gonna happen until I call something like a count. This is an action, and the count is going to trigger this step here, what we see in the explain. Does anyone have any questions there? No? Okay. But yeah, this is one of the perks of working with Spark. And this is one of the reasons why it's able to handle large amounts of data really well when compared to Pandas. It's because some functions like filter or what else? Like filter, select, group by, with column and join. Those are all examples of transformations, and nothing happens until you do something like a count or a collect or another action. But I'm going to go ahead and take a 5-minute break here because I need water. Yeah, I still need to tweak the slides a bit, and then I'll post it in the same description where the Colab link is. Yep.
So you ran Siri.
Just gonna
Slow down a bit. Did you use it has multiple it's because go up.
Were you able to run
Yeah, you need to
cells
set
in
the
or in the Colab?
I am up to, I just finished running filter and ratings count,
not in
Okay.
and I'm about to hit the explain for this one.
Awesome.
This is a second.
you need to use it.
Yeah, after that one that took like 5 minutes or whatever, then they're
Yeah, there's
mostly going.
2 files in my list and I'm
The last one, the count one, took just enough time that I decided to go get water while running and just done whatever that.
Okay, yeah. I need to explain to that.
I'm still on break because I haven't.
Yeah, we're still on break.
Okay, so I was just looking at your website, and I actually just started writing a similar thing.
Yeah, I'm on LinkedIn.
Cool. I'm sending.
Oh,
I will. Also, I enjoy, and so I will message you when I send you the thing.
Awesome. Nice to meet you.
Nice meeting you.
We still have like 3 minutes of break.
I think that's a shocking thing to say. It's a shocking thing. Just say he had a bad game. Just say he didn't have his best.
Cynthia, is it anime list and anime that you're uploading?
Yes. Yeah, there's 2 different CSV files. The larger one is anime list, The naming for this is pretty confusing, but the enemy list contains behaviors of
Right.
the users, like what they like and what they watch.
Right.
While the enemy list is just the description of the series.
Okay, and then in spark.read.csv, am I uploading both?
You shouldn't be uploading anything. Were you able to add the shortcut to your Google Drive?
I did, and so I've got this, and I'm definitely missing a step. So I've got anime list, and then some of it ran, no problem. And then this, I'm trying to figure out, I'm wondering if it's just the wrong file that it's analyzing.
Oh, it's 410. Or actually no. No. Can you go back down?
Sure,
Or to the error?
sure, right here. Is it just an error with the way that it's written?
Go back to
Sure.
one. Oh, yeah, it should be. Let me see F.
It's going to see.
Is it the right path?
Yeah, I have to copy the copy.
So he's able to get the other cells running.
Yeah, everything else ran.
I think it's the data frame name.
Oh, no kidding.
Let me see what I have.
Yeah, no problem.
Which cell is it that's not running?
It is. It is right after correcting a column's data type.
Is this one here?
Yep, it is that one there.
Okay. When you ran schema,
Unless there's something I've done wrong.
I think this is the schema for anime list, but that's not the schema for anime.
Right, should
I
I be
think-
running?
Go up.
Sure.
Let's see. Okay. This is it.
So this should be anime.
Yeah.
Okay, that's where my confusion is.
Yep.
And we're not uploading anime list, just so I'm clear.
No uploading.
Okay.
Yeah. You should create a shortcut for both anime list and anime.
Yeah, that I have. Okay, no problem. Thank you, Cynthia.
Welcome. Okay.
Yeah.
Great.
Yeah, I screwed up.
So let's go ahead and continue. And there's no screwing up. This is a learning course. We're all learning here. Okay. So this blurb here is about parallelism in PySpark and Pandas. I'm not really going to go into it because we kind of went over it, where Spark is just splitting files into chunks versus Pandas that reads everything at the same time into RAM. Here is some basic data cleaning that you can perform using PySpark. It's very similar to Pandas, so whatever you can do on Pandas in terms of data prepping and cleaning, you can do with PySpark. So here I'm running this counter to see if there's any empty or missing values in the columns for the filtered ratings data frame. There's nothing here. And I'm also running that same query on the anime's data frame. And here are some discrepancies. So that's that for counting the number of null or empty values. Any questions there? Okay. So now we're gonna get into mutability between Pandas and PySpark. So one of the annoying things about Pandas is that you can make changes to your data frame in place. But with PySpark, your data frames are immutable. So once it's created, you cannot change it. And every transformation always returns a new data frame. And I did have a question. So what would happen if Spark acted like Pandas, where it did allow for mutability? Like what could go wrong if Spark, yeah,
Could end up with data on the wrong node. It's aggregating.
for sure. Anything else?
Because if you have a function that like combines data from different nodes, maybe it's like reading an older version of the data.
If it loses a partition, yeah, it's going to give you the wrong version. It needs a copy.
Right. These are all really good. Anyone else?
Well, I think the manager is making assumptions on what's coming back, right? For instance, to aggregate all the results. And if the supervisor or the manager all of a sudden got a different data type back or a different value that it didn't expect, it wouldn't be able to aggregate it, right?
Right. So, yes, if Spark was able to allow for its data frames to be mutable, it would be hard for the manager to track changes. It would also fail in like parallelism. And this is because, let's see, it would cause race conditions. So if multiple executors were working on the same task or they were given a task, like the driver wouldn't know what to accept if they were making changes to the data at the same time. The DAG wouldn't be created, so fault tolerance would be eradicated. And did I go over the DAG? I think I went over it, that it's like a workflow. But the DAG is really important because if a job were to fail, that allows Spark to go to like the last checkpoint and rebuild or rework that job from that safe checkpoint. So if PySpark or Spark allowed for mutability, there would be no DAG. So if a job failed, it would have to recompute the whole thing all over again, which would be a disaster if you're working with huge amounts of data. Anyone have any questions? Nope. Okay. So again, Spark needs to keep track of the DAG. It also needs to recompute or recover partitions in case of failure. And immutability allows for distribute transformations across the machine safely. So fault tolerant, it's optimized, and it allows for parallelism when things are immutable. But with Pandas, like I said before, you can change a Pandas data frame in place, which is harder to keep track of changes. It's not fault tolerant, and this can lead to bugs. I'm not sure if anyone has ever had this issue where you're trying to do some analysis work in a Pandas data frame, but you save over, like you save the same results to the data frame and you aren't like keeping track of your changes. And like when you go back to your code, you forget what you did. So it's hard for you to reproduce those results or something like that. I'm not sure if anyone's experienced that, but I have. And I wish there was like a git commit, but you know, like a data frame commit for your data frames every time you make a change. That would be nifty. So here are some other data manipulation or data pre-processing that we can do with Spark. We can create new columns. So this first block of code here is creating a genre array. And we're going to basically split the values in genres by the delimiter, this comma, and it's going to produce this here. And the show, we're gonna show like the top 5, and false here just means we don't want to truncate our view of the text. So we wanna see everything in that view. So that's the first part, and then the explode will flatten the array. So with explode, we're gonna take each of these items in our list and then separate it. But explode can be kind of dangerous because you're working with huge data. So you could have an even larger data set because of that. So that's explode. And then we also have a filter here. We're just filtering on the column that has this MAL-ID 120, and it shows us Fruits Basket. So I'm not sure if you all have watched Fruits Basket. Has anyone else? Okay. All right.
Seen the memes.
Oh, okay, yeah. Awesome. Oh, I forgot to ask if anyone has watched Cowboy Bebop at least, or yeah? Awesome. No? So here are some more string cleaning or more cleaning that you can do on your Spark data frame. So it's like a cheat sheet here. I'm not going to go over the whole thing, but this is just something nice to have and look over. If you are planning on using Spark on your own, you can refer to this. And on to shuffling. First, let me see. Okay, cool. All right, so on to shuffling. Shuffling is shuffling. It's a process that is necessary when you're doing wide transformations, but shuffling is very expensive. And this is because Spark is moving around data to different executor nodes within your cluster. And this is where a lot of the runtime can be attributed to, is because of shuffling. So what exactly is it? In this example, I'm doing a group by user ID, and then I'm doing an action, which is count. Oh, I wanted to go over what you mentioned. So you ran your code, and when you were running the count, it took you quite a while, right?
Yeah, not as long as that one cell, but like the second longest thing.
Okay. Yes, and this is because actions execute the plan. So when you perform an action, that's when the DAG gets, finalized, or Spark actually puts the DAG into execution. So that's why it takes so long for an action to perform. But with a lazy evaluation, nothing is actually happening, which is why those cells where you're doing a lazy eval is so quick and you see a result or you don't see anything right away. But the actions take quite a bit of time. So here with the shuffling, we're doing a count on this group by. And so what Spark is doing is it's moving all the rows that have that same user ID to the same partition so that it can count them. And this can cause a lot of issues, especially when you're working with large amounts of data. And this can also lead to skewing in the cluster if a partition has like a majority of the data. And I'm going into some of the like optimization of it, and you can stop me and ask questions here. But if we have like let's say we have 10 user IDs and one user has like 20% of the data that we're looking at, and it gets sent to that particular partition, that can cause skewing, which would not be well optimized for our Spark job, because all the other executors, they'll basically be finished with their task, while the one lagging behind is the one that has all those user IDs associated with it. So what's something that Spark could do to alleviate that issue with there being skew in data?
We just split it up across multiple nodes and have the manager bring it back together?
Yes, it does something like that. So with repartition, in the background, it like splits up that one big massive key into smaller keys using like a hash or something like that. So essentially it does get sent off to different executors, so you no longer have that skew. But that is something to consider if you want to get into the nitty-gritty of it. But if not, then you don't have to worry about shuffling. Just realize that it is the most expensive thing that you will probably perform when working with a PySpark job. So yeah, if you ever do run a PySpark application and you've noticed that there's an issue with performance, there's some sort of bottleneck, or you're getting a lot of out-of-memory errors, it's probably because the data is poorly partitioned, there's some sort of skew, or there's something going on with your data shuffling, and you might need to repartition again. Another thing that you can do to alleviate this is to do a broadcast join. So this is a special type of join where a smaller data frame is serialized and sent to the other executor nodes. So each executor has a copy of the smaller data frame. And so rather than doing a shuffle where you're shuffling all the keys and trying to aggregate them together, your executors have that smaller data frame that they can refer to, and they'll do that join locally. Any questions there? Okay, so this is an example of doing a broadcast join. You don't have to explicitly do a broadcast join. Spark can do that on your behalf. That's one of the benefits of doing Spark is the Catalyst optimizer, and we'll go over that later. But it does a lot of the optimization for you, so you don't have to worry about that yourself. So in this next cell here, we're doing a group by, and then we're doing an aggregate on that group by. It's just showing you how to, call some of these functions. Same here for this one. And then onto the Spark SQL, which is really cool. Who here uses SQL? A lot of you. Okay, awesome. When you're working with Pandas, do you use SQL on your Pandas? No. Yeah, like SQL Alchemy, I think that's the library, or do you use something else?
PanSQL is one you can use.
Okay. How's the setup for that? Is it kind of painful to get that working or no?
No, it's just another import.
Okay. So with Spark, it does have a SQL API built on top of it, which is really nice. You don't have to import anything or install anything. What you need to do though is create a temp view for the table that you're referencing or the data frame that you're referencing. But the query is like any other SQL query, and then you just pass it through spark.sql, and it will create a data frame. But this is the same, it produces the same result that we did prior in the first couple of cells. We were trying to find the number of nulls or empty values in our anime data frame. Any questions there? No? Awesome. Okay. I feel like I have questions for y'all, but I haven't been asking them. Okay. That's fine. So off to the Catalyst optimizer. This is a Spark's engine. It's the brain behind Spark, and it optimizes a lot of the SQL queries. It's the JVM process. I'm not going to go too much into it because it's a lot. But basically, when you're running something like this filter, the Catalyst optimizer is going to produce, it's going to perform some steps on that query in order to make it run faster, which is really cool. So Spark will consider multiple ways to run your query, like should it use a sort merge or a broadcast join? Should it use a hash aggregate or sort aggregate? So you as the analyst don't have to really worry about optimizing your code. You just put in the transformations that you want to make on your data frame, and the Catalyst optimizer will do that heavy duty work on your behalf in the background, which is really nice. So here we have some other optimization hacks like caching. So Spark doesn't automatically cache a data frame for you. But you could cache. This is a way for your code to run a little bit faster. So rather than you having to recompute the same data frame over and over again, you can save it and use it immediately through caching. And Pandas doesn't have something like that, unfortunately. You can also increase the number of partitions, like to alleviate any skews that you see in your Spark app. And here are some code patterns. I'm not going to go over this. These are more like notes that you can refer to later. Just basically telling you like how you can format your code to make it more legible or easier to read. Yeah. Let's see. Okay. So when should we go back to Pandas? So there's a few reasons why we would want to go back to Pandas. So maybe we're done applying the transformations that we want on our PySpark data frame, and we want to conduct some analysis on a sample, or we want to visualize what we have, or do some modeling. Spark has those capabilities, but it's not as good as the libraries that we have in Python, which is why you can create a Pandas data frame from a Spark data frame, and vice versa if you wanted to. But this is just an example of me creating a Pandas data frame from our users who completed the series. Okay, and I would like to know, one moment. Okay, so which of your current workflows could Spark replace now that you have a bit of understanding of Spark? Where do you think you could use Spark in? Anyone want to share?
I think I would want it to be somewhere between my data repository and my data scientists, so that they are able to access data that's bigger than conventional methods allow.
Okay.
And architecturally speaking, I'm not sure how I would do that.
Okay.
I feel like that's where, if I wanted to, organizationally, I would use it as an enabler for the data scientists on my team.
Okay. So like you run an ETL process on it and on some large data, and like the final data product is something that your data scientists can use for their models?
So we end up with, through our data acquisition system, we end up with hundreds of thousands of multi-terabyte Parquet files. And they're in a NAS, just stored. And I feel like I would want Spark at a point where I would be able to digest a subset of those to build data sets.
Okay, now that's a really good use case for Spark. Anyone else want to share?
I work for a graph database company, and one of the issues that a lot of people run into on importing is that when you're working with a graph, instead of just appending rows, a lot of the time you're trying to search for and edit data that exists in the graph. And if you're parallelizing things like relationship loading, you might run into issues because you might have multiple queries trying to touch the same nodes at the same time to build relationships. And so recently we've developed a parallel loading capability that uses Spark. And so it will split up the data in a way that can be parallelized without running into issues with deadlocking with parallelizing those relationship loads.
That's cool. Anyone else want to share?
I kind of want to be able to develop against 1 million rows or something, but then scale out using the same code. I'm not sure how well we'll be able to do that with this, with the PySpark.
Yes, so you could scale out by pointing your logic to a different cluster. I don't think I did a good job in explaining that earlier, but here is where we set our cluster resource, or where we set our cluster. In this demo here, we're saying we're setting our cluster up locally and we're using all resources. But if you had like a yarn or like an EC2 instance that has a Spark cluster that you wanted to point to, you could just replace this string. And that's scaling for Spark, which is very easy. It's just pointing to somewhere else.
Okay.
Anyone else? Any questions? No?
We use Databricks a lot, which is inventor of Spark, right? So it's out of the box basically. So it's the clusters are provisioned either with Azure or AWS. And now we have a facility to make your IDEs using Databricks Connect. With VS Code, Python, connect to Spark cluster and run it. Develop locally but run remote.
Oh, that's nice.
So
Yeah, Databricks allows for hosting and managing So if you don't have a dedicated IT team to do all that work, then Databricks for sure is a good option. Anyone else want to share or no? Okay. So that's pretty much it for this demo. I had some frequently asked questions here that I posted, but if anyone else has questions overall, ask away. We have like 20 minutes left.
How does Spark compare to normal Hadoop in runtime on the same data set and performing the same actions?
Oh, I didn't do something like that, but I don't want to speculate. Earlier I did say that with Hadoop, developers were experiencing the issue of it reading and writing to disk a lot. So that had runtimes being slow, whereas with Spark, the data is loaded into memory as much as possible. So there isn't that intermediate writing to disk and then reading from disk. So theoretically, Spark should be faster if you're running the same tasks on that large data set, because it's not doing that reading and writing to disk.
Is that assuming that they have the same workers available?
Yeah. That's a good thought experiment. Any other questions?
Is it a correct understanding to think of Spark as something that should be integrated with your infrastructure planning rather than used in an ad hoc manner?
Yes. At least that's what I saw Spark being used at my prior company. Definitely a part of the infrastructure team, so we would get the raw data, well, not my team, someone else would handle that raw data and turn it into something more legible and then store it into S3. And then my team would pull that Parquet data from S3 and then do a whole bunch of transformations on it to make it useful for our data scientists. And then they would do what they wanted with that data.
So once you had made the transformations using Spark from the S3 stored Parquet files, did you then move it into a different, like a warehouse, or how did you expose that to the downstream users?
It was also in S3, but a separate S3 bucket.
Okay, so you would write it back into Parquet, back into S3 in a different bucket. Okay.
Yep. Anything else?
To make it user friendly or usable, now there is something called delta tables, which is you just run SQL on files. It appears like a table. Parquet files, a collection of Parquet files, kind of like a table.
Nice. Okay. Well, that's the end of my
Thanks for coming, and we were so excited to have you for this session.
Thanks.